histogram is a type of graph, very similar to a bar chart, except it is used with interval or ratio data. As a result, the histogram clearly allows us to see the shape of our data. Because the data are connected to each other, the adjacent bars in a histogram do touch. We could not arrange the numbers 1 through 5 to run 1, 4, 2, 5, 4. They must be in numerical order, and each bar is therefore connected to the next. Like the bar graph, the vertical bars are centered over the scores on the x-axis. The width of the bar corresponds to the real upper and lower limits of the interval. So, for example, the bar for the number 4 actually includes all data points from 3.50 to 4.49 because of rounding. The edges of the bar will be at those points. So histograms help us to identify the shape of a distribution, such as when it is bimodal, skewness, such as a positive skew, kurtosis, the spread or the variation in the scores, and unusual scores or outliers. Returning to our clickers.sav dataset, a teacher wanted to know whether students who share a single clicker with a group participate in an interactive exercise more or less than students who use individual clickers. She measured participation among 166 seminar participants after each of 3 rounds of group interaction. So level of participation is our dependent variable. We are going to focus on the results from round 1. Participation was measured using a Likert-type rating scale with scores ranging from 1 to 7, where 7 equals high participation in the group and 1 equals low participation in the group. Remember those ranges, 1 to 7, because that will be important in a moment. You may also recall that when we created a bar chart with error bars, we noticed that the error around the mean for round 1 was greater than for the other rounds. The error bar was larger. I suspect that we may have some outliers causing that. Let's use a histogram to get a closer look at our data. In SPSS, go to Graphs, Chart Builder, click Reset if there are still data in the chart builder, and start with the gallery. In the gallery, this time, choose Histogram. Drag Simple Histogram up into the canvas. Under Variables, drag the participation from round 1 into the x-axis, and notice that the y-axis changes to histogram by default. But in the element properties, we can change the statistic for histogram to histogram %. Now click on Set Parameters. Under Anchor First Bin, choose Custom Value for Anchor and set the value to 0. Under Bin Sizes, also choose Custom and then set Interval Width to 1. Now click Continue, click Apply, and click OK. Now check the histogram. Does this look like what you expected? See any problems? Let's look at this more closely. Yes, in fact, it looks like we have an outlier. In fact, we have 2 outliers. Or as the great philosopher Rick Perry once said,
oops.
The histogram does not look like what we expected to see. The values are supposed to be between 1 and 7, so it looks like something may have gone wrong. And we are going to need to do something about that. We're going to sniff out the outliers with a box plot.